So I'll roughly draw out this graph, the values here. So we have 0, 2, 4, and 6, and that's the interval we're looking at. The values are, and I'm going to draw a different scale here, 2, 3, 4, 5, 6, 7, 8, 9. So at 0, it's 9, and then at 2, it's 5. So in the exam, if you're doing this, you just have to draw it out roughly. And then at 6, it's 1. And they're asking us to find the left Riemann sum and the right Riemann. So I'll start with the left one, where the rectangle that you draw. So essentially, we're trying to estimate the Riemann sum, which is an approximation to the integral or the area under this curve. And what we're going to do is to use the left value to create these rectangles. And that's what I'm doing here. So the sum of these three rectangles would be the left Riemann sum, because left meaning we're using the value to the left end of that rectangle. So here that's 9. Each of these is 2. And this is 5. So area of that one is 9 times 2. This is 5 times 2. And then here this is 3. So that's going to be 3 times 2. So the left Riemann sum, L, is 18 plus 10 plus 6, so 34. And then I need to find the right Riemann sum. And let me actually draw it here. Let me use a different color, actually. It'll become easier. So we're going to use the right value. So that would be the first rectangle. Here, this would be the second. And then finally, this would be the third. So this sum of the area of these rectangles would be the right Riemann sum, right referring to the value of the height of the rectangle is the value at the right end of the function. So here, this area would be 5 times 2, because note that's 5. And then this would be 3 times 2, and then 1 times 2. So R would be 10, that plus 6 plus 2. So R is 18. They're looking for absolute value of their difference, which is 34 minus 18, which is 16. And that's answer choice D.